It's not a meteor. It's not an alien ship. It's space junk. Right now, there's an object hurtling around Earth so fast and in such a hazardous orbit that it could kill a satellite, or even an astronaut, in seconds. The debris we left behind is becoming the greatest threat to our ability to use space. Welcome to the era of the most dangerous object floating near Earth. Why space junk matters. Space has always been portrayed as vast emptiness. But for low Earth orbit, or LEO, that image is misleading. Thousands of satellites, defunct rockets, discarded tools, paint flecks, and fragments now circle our planet at tens of thousands of kilometers per hour. At those speeds, even a speck of metal can strike with energy equivalent to a bullet. That's why space agencies call this debris orbital shrapnel. Every object in orbit must dodge this junk. Some collisions create new debris, triggering chain reactions known as Kessler Syndrome, a cascade of collisions that multiply fragments exponentially. That scenario could render entire orbital zones unusable for decades. The famous threat: Envisat, SKA, and debris. Some of the most infamous pieces of space junk are large, out-of-control satellites. Take Envisat, an ESA Earth observation satellite launched in 2002 and lost in 2012. It weighs 8 metric tons, and its orbit is at about 785 kilometers altitude. Because it's dead, it no longer maneuvers or avoids collisions. It's effectively a giant, uncontrolled projectile in orbit. Then there's SL-4 rocket bodies, defunct upper stages of rockets from old launches. These big hulks often carry residual fuel or pressurants, and though dead, they still pose collision risk. But the real danger often comes from fragments. When a component ruptures, a collision occurs, or even from past anti-satellite tests, it creates hundreds or thousands of smaller bits. These fragments are nearly impossible to track once they fall below certain sizes, yet they can still travel fast enough to cause mission-ending damage. One recent close call involved the Tiangong space station being forced to maneuver to avoid collision with debris estimated at less than 10 centimeters in size. That's about the size of a coffee cup, but at orbital speeds of around 28,000 kilometers per hour, it can tear through systems. The most dangerous object. So which object is the most dangerous? There isn't a single official candidate, but many experts point to massive non-functional satellites like Envisat, the upper stages in sun-synchronous orbits, or large fragments from past collisions. What makes one debris piece especially dangerous? Mass and size, large enough to impart energy, unpredictability, no maneuvering capability, high-risk orbital paths crossing many operational satellites, fragmentation potential, likely to break into many smaller dangerous pieces. Some mission planners consider Envisat a top contender for most dangerous because of its size, altitude, non-functional state, and cross paths with many operational satellites. Real collision risks and close calls. We've already seen near disaster. In 2009, the Iridium-33 satellite was struck by the defunct Cosmos 2251, a Russian satellite. That collision produced over 1,000 trackable debris fragments. That single event escalated the debris field dramatically and is often cited as the wake-up call for space operators. In 2021, SpaceX had to perform debris avoidance maneuvers 6 times for its Starlink satellites. Even the ISS occasionally adjusts orbit to dodge predicted debris passages. Scientists estimate that there are over 128 million pieces of orbital debris smaller than 1 centimeter, untrackable, and over 900,000 pieces between 1 and 10 centimeters. These small objects are the greatest hazard, too small to track, too fast to mitigate, and still capable of catastrophic damage. How we track and avoid debris. So, how do agencies manage this? 1. Space surveillance networks. Agencies like the US Space Force and ESA maintain catalogs of debris larger than 5 to 10 centimeters. They use radar and optical telescopes to track orbits, predict potential intersections, and issue collision warnings. 2. Shielding and redundancy. Many spacecraft are built with shielding, Whipple shields, that can absorb impacts from tiny debris. Redundant systems help survive single-point failures. 3. Collision avoidance maneuvers. Satellites with fuel reserves can perform small nudges to avoid predicted debris passes, but this consumes propellant and shortens mission life. 4. Active debris removal, or ADR. Proposed technologies include robotic arms, nets, harpoons, lasers, or drag sails. Some experimental missions aim to capture and deorbit defunct satellites, but the risk, cost, and legal questions are high. 5. Passivation and deorbiting protocols. Future satellites and rockets are designed to vent residual fuel, lower orbit at end of life, or re-enter safely. But many legacy systems never adopted these practices. What happens if the most dangerous one hits? Imagine EnviSat or a similar massive piece collides with a working satellite, like a communications or weather satellite. The cascading fragments could end an entire constellation, cutting off communication, GPS, Earth imaging, or even weather forecasting. If a fragment hits the ISS, it could puncture modules, damage life support systems, or require crew evacuation. Space tourism, scientific missions, and future Moon-Mars missions also risk being impaired. If the orbital lanes become too dangerous, many operations could become prohibitively expensive or risky. A worst-case scenario, a Kessler cascade starts. One collision generates debris that causes more collisions, leading to an uncontrollable debris swarm. Entire orbital bands would become unusable for decades, possibly centuries, until atmospheric drag naturally clears small pieces. What we can do going forward? The threat is real, but solutions exist, if we commit. International cooperation is critical. Debris knows no borders. Legally binding treaties to require deorbiting or removal of defunct satellites. Funding for active removal missions and debris cleanup techniques. Designing future spacecraft with end-of-life plans and debris-safe modes. Improved sensors to track smaller debris and predict more collisions. Private companies are also stepping in. Some propose junk collector satellites. Others suggest using ground-based lasers to apply small forces that lower debris orbits until they re-enter safely. Time is not on our side. The longer we wait, the worse the debris problem becomes. The big, silent danger floating near Earth isn't an asteroid or comet. It's our own waste. A defunct satellite careening at 28,000 kilometers per hour could erase decades of space infrastructure. We're barreling toward a moment when orbital space becomes so polluted that access to space could be denied to all but the richest. But we still have a chance to act. Now, if you found this video eye-opening, hit that like button and subscribe to Cosmic Crunch. Drop a comment. What piece of space junk scares you the most? EnviSat? A fragment? Or what's next?